Hey everyone, how's it going? This is Fundamental Statistics in Excel conducting an ANOVA, analysis of variance. We're going to kind of go briefly over just kind of what this is, give you kind of an example, a high-level example, so that you can use it in your application going forward. Just give you a sense of this, of what happens. And there's be other subsequent videos as we kind of get on with questions. They're kind of more specific examples and scenarios and those things. But this is really just a broad overview of this function and how it works in Excel, in our Excel-based course. So, ANOVA is a statistical method used to test differences between two or more means, similar to the t-test, but just a little bit different. It may seem odd that the technique is called analysis of variance rather than the analysis of means, but as you'll see, the name is appropriate because the inferences about means are made by analyzing the variance of those groups. So it's just a little nuance I wanted to point out to you and just let you know just ahead of time before we kind of jump right into Excel. So what we'll do is we have our group right here, the east, the west, and the south. We have these values, just miles between the next town or something. Just numbers to kind of compare regions, square miles of towns. So what we want to do is first we want to actually do this, do a single factor ANOVA. So what we're going to check is our handy dandy data analysis tool tab right here. And then we're going to do a data analysis right here. So we're going to go all the way back to the top. We want ANOVA single factor. That's what we want right now because we're just doing this based on a single factor. We're not getting into it with or without replication, those kinds of things, which we can get into in other videos. But basic with ANOVA is a single factor. So make sure we have our input range. It's a little different than the regression. What we want to do is to upload all of these at once, like that. And so we want the labels in the first rows, of course. Remember also that alpha is 0.05, so if they say we'd like to set a 95% confidence level, what that really means in terms of inputting it for the ANOVA is 0.05, so 1 minus 0.95. And what we want to do is do the output range here too, so we can kind of see what we're looking at. We'll just put it right here for comparison. So we have just a little bit. Let me just move this around, give some space to it. Okay. So there's lots of information to kind of process here. And what we want to do, so there's a lot of info, but what you're really after, what you're really looking for is between groups. The p-value between the groups. So our degrees of freedom, just as a quick review between the groups. Within the groups, 21 is kind of giving you overall. It's the n with the sample size minus 1. The p-value is really what we're interested in. So the ANOVA test attempts to detect a signal of genuine difference amidst all the noise of other data points. More precisely, it partitions the natural variance within the groups, which is the noise, I guess you can call it, from the variance between the groups of the signal. So if the difference between the groups are substantially greater than the difference within the groups, then we can say there's a strong signal-to-noise ratio. And the stronger the signal-to-noise ratio, the lower the p-value. So based on this, the p-value, it's greater than 0.05, or alpha. So it's not really statistically significant, but it is lower. So it is signaling a slightly stronger signal-to-noise ratio. So that's what we want to say. That's what we want to get to. So in summary, what this really means is that the difference between the groups is becoming greater than the difference within the groups. So the between the groups is different. Now, kind of presenting this visually. So the difference between the groups, so like from east to west to south, is starting to be greater than the difference within the groups. So it lets you know that you are comparing the groups and it's a good comparison across the categories, and that the means are different, but they're not statistically different. And we can get into more kind of how the cross-pollination of everything, but this is just a broad overview of the function. ANOVA is a very useful function in comparing means and larger data sets. We hope this helps your understanding, and just let us know if you have any questions along the way. Thanks very much.